Ladies and gentlemen, it's my great pleasure to attend the Expo Clean Energy 2023 online. Thanks a lot to Professor Artur for his invitation. The presentation is about the recent research work in our group on solar power generation and PVT heating. I am Yanjun Dai from Shanghai Jiao Tong University, China. I hope the exchanging will be helpful for further develop the collaboration between two sides. My presentation including 4 parts. Part 1 is a beam down solar CSP technology. Part 2 is solar photovoltaic thermal module. Part 3 is a solar heat pump technology, and Part 4 is a residential solar tree generation system. The beam down solar concentrated power generation technology is nothing new, just replace the solar power with a secondary reflector. It means the molten salt reactor can be moved to the ground, which minimizes the investment and cost on tower construction and increase the operation durability and make it more reliable for the whole system. The picture shows the real operation state of the beam down solar CSP station. At present, we have finished a 50 megawatts CSP plant in western part of China. These two figures shows the layout of the mirrors and the second reflectors. The tower is operated smoothly and can produce the high temperature as 600 or 6500 degrees C. It's high enough to effect the high efficiency thermal power dynamic cycle. Part 2 is solar photovoltaic thermal module. As we know, solar cell or PV is the most rapidly developed energy technology. The conversion efficiency is above 20%. However, there are still about 80% of the energy is converted into heat. If the heat cannot be rejected efficiently, the temperature of the solar cell will be increased, which means the power generation will be decreased. So our technology considered to cool the solar panel efficiently. Meanwhile, harvest the heat from the solar PV panel for further hot water or for space heating purpose. In this case, both electricity and heat obtained. The electricity generation is improved by almost 20%. The right two figures show the products developed in our lab of the solar PVT module. Here shows the solar PVT whole system. Using PVT module, we can produce as much as possible electricity, meanwhile get hot water or heat for space heating. If the panel heat output is not so high in temperature level, we use heat pump to furtherly lift the temperature to meet the demand for hot water and space heating. Under typical sunny days, the COP of the system for heating is as high as 7.0. It's much better than the traditional air source heat pump. And also, the total solar energy conversion efficiency is as high as 80%, which is one of the highest efficiency for solar energy conversion process. Here, I would like to show you the maybe working principle and also the maybe fabrication process of solar PV panel. This is a cooling panels of the PVT module, and this is the PVT products. The PVT products integrate the cooling panel and the traditional PV together, but it's not simply two put one. It's a purely integrated product, which means we minimize the heat transfer resistance and increase the efficiency significantly. The system can be used for maybe residential hot water production, for space heating, for roof PV power generation, meet the demand for house electricity supplying, heating supplying, and so on. Yeah, it can be used in maybe household roofs or public building roofs and other applications, and is of potential for the market, large-scale market. Today we have produced about 2 megawatts real project. Here shows the fabrication process. It's very easy and reliable. Here shows the temperature decrease effect. It means compared with the traditional PV module, the temperature is lower than maybe about 30 degrees C. It means maybe 10 to 20% electricity more can be produced with our technologies. Part 3 is the solar resorption heat pump. Using this technology, we can realize the maybe so-called the double maybe or increase the solar thermal output significantly using heat pump thermodynamic cycle. We developed the ammonia water resorption heat pump dynamic cycle, which lower the requirement of the temperature for solar collector and also increase the system COP significantly. We have successfully commercialized this kind of heat pump and put it into real application for space heating in northern part of China, cold or very cold regions. Part 4 is a residential solar tree generation system, which means we can use PV or solar collector on roofs to produce electricity and heating to meet the demand for building electricity, building heating, cooling, and also hot water generation. If the electricity cannot be used locally, it can be transferred to the grid. Also, the heat or the electricity can be stored for maybe maximize the cost issues. We have successfully developed the maybe home used appliance to harvest the solar energy and the ambient energy for heating, cooling, hot water, and electricity. It is of potential and is of largely application potential in China and other countries, and is helpful for construct the net zero carbon emission buildings. As a concluding point, we can see solar energy will copy a hero in the maybe future energy structure, and the beam down CSP minimize the requirements and cost on tower construction, and is of potential for solar CSP technology market. Solar PVT modular increase the electricity output and get heat at the same time. Solar heat pump is the best solution for heat supplying without intermittence. And for future buildings, the residential solar tree generation technology, namely heating, cooling, electricity supplying, will be more and more important. All these technologies, I think, is feasible not only for China, but also is of potential for Chile's application. So that's my brief introduction about our work in our research group. Thank you so much. Thank you.